Welcome to the second module of day 10 of this course. I'm Amy and I'll guide you through permutations. Feel free to pause the presentation at any time. Firstly, what is a permutation? A permutation is an ordered arrangement of a set of objects. Let me put this in context with an example. If a set consists of the letters A, B, and C, there are 6 different permutations as you can see here. If a set consists of n distinct objects, a permutation of that set will have n choices for the first place and n-1 choices for the second, and so on. For the last object, we will only have one choice. By using the multiplication principle, we find that the total number of permutations of a set with n distinct objects is given by n times n-1 times n-2, and so on. Let's go through an example. If a set consists of the numbers 1, 2, 3, 4, and 5, how many ordered arrangements or permutations are there? There are 5 numbers, so the permutation is 5 times 4 times 3 times 2 times 1, which gives us 120. Thus, there are 120 ordered arrangements. It becomes tedious writing down n times n-1 times all the way to 1 every time, so we have a shorthand notation called the factorial notation. For positive integers n, the factorial notation, which is denoted by n exclamation mark, is defined to be n times n-1 times n-2, and so on until 1. This is read as factorial n or n factorial. 0 factorial is defined to equal 1. The integer n factorial is a number of permutations of n distinct objects. In the first example, we saw that there are 6 permutations for the letters A, B, and C. By using the factorial notation, there are 3 factorial permutation, which equals to 6 permutation as we saw earlier. Now that we know what factorials are, let's go through a few examples. Let's evaluate 4 factorial, 6 factorial, and 5 factorial over 4 factorial. 4 factorial is simply 4 times 3 times 2 times 1, which equals to 24. For 6 factorial, we can simply multiply out as with 4 factorial, but notice that 4 times 3 times 2 times 1 is equal to 4 factorial, which we know is equal to 24. So we can write this as 6 times 5 times 4 factorial, which equals to 720. For 5 factorial divided by 4 factorial, by expanding the factorials, we can see that everything aside from the 5 gets cancelled out. Thus, 5 factorial divided by 4 factorial equals to 5. Alternatively, since we know that 5 factorial equals to 5 times 4 factorial, we can simply cancel out the 4 factorial rather than expanding the whole thing. Next, let's talk about choosing an ordered set. In many cases, we want to find out how many ways we can choose an ordered set from a number of distinct objects. There are 2 ways of choosing a set, one without repetitions and one with repetitions. First, we will go through the one without repetition. We use a notation NPR, which is read as n permutation R, to represent the number of ways we can choose an ordered set of R from n distinct objects with no repetition allowed. There are n choices for the first object and n-1 for the second, and so on to the rth object where we have n-r plus 1 choices. So n permutation r equals to n factorial over n-r factorial, which equals to n times n-1 times n-2, and so on until n-r plus 1. If we are allowed to have repetitions in our choices, then there are n to the power of r ways of choosing an ordered set of r from n distinct objects. For example, how many ways can we line up 4 students chosen from a class of 20 students? In this case, n equals to 20, r equals to 4, and repetition is not allowed, so we have 20 permutation 4. By calculation, we get 116,280. Hence, there are 116,280 ways of lining up 4 students chosen from a class of 20. Here are some practice questions for you to do. Pause the video and have a go at them. More practice questions for you? The answers are on the next slide. Pause the video when necessary. Here are the answers.